Assalamu alaikum. Today is our fifth lecture of DSP. The main content of this lecture is fast Fourier transform. We will study about fast Fourier transform. The formula for DFT as we previously discussed is xk is equal to summation n0 to n minus 1 x of n e की power minus j2 pi k n over n. In the previous lectures we discussed about the sorting techniques. We have two sorting techniques: unsorted and sorted data, linear search and binary search. In linear search the worst case analysis is O of n, and in binary search the worst case analysis is O log 2 base 2 n. If we have additions and multiplications in discrete Fourier transform, worst case is addition n into n minus 1, and in multiplication n into n. So in this case we have n into n minus 1 and n square. In DFT the worst case analysis for multiplication is 10 power 22, and in worst case analysis is 10 power 24. Now we take signal having 8 samples. X of n, the signal total number of samples is n is equal to 8, as we have previously calculated values from x of 0 to x of 7. Now we write down these values here. The graph, we are familiar with this graph, real part and the imaginary numbers. In addition we have 8 samples, so according to the addition formula 8 into 8 minus 1 is equal to 56, and in multiplication 8 into 8 64. The formula which previously discussed is x of k at DFT, discrete Fourier transform formula. If we replace omega n here, which is equal to e power minus j 2 pi over n. Now we plug in omega of n here. In the formula for discrete Fourier transform we plug in omega of n. We have different values of omega n. Omega n from n to n we have 1, omega n from k to n we have 1, and n to n by 2 we have minus 1. So these are the different values for omega n which we discuss further. In fast Fourier transform n is equal to 2 power n. We partialize the formula of Fourier transform into two parts, for even signal and odd signal. For even values and odd values, n by 2 is the half the samples. If we divide this n by 2, put n is equal to 2r and plug in this formula. Here we have omega n power 2 r plus 1 into k. If we multiply 2r into k and plus 1 into k, so this term is without k, so we plug it outside of the formula. This is how we merge even and odd number of our data. Even values plus omega n per k plus multiply by odd number of values. So the finalized formula x of k is equal to a plus omega n per k into b. Now comes to our 8 sample signals. In 8 sample signals we divide into even number of signals and odd number of signals. For even values we have 2, 3, minus 2 and 3, and odd number of values is minus 4, 1, 0 and 1. We separate out these values here: 2, 3, minus 2, 3, minus 4, 1, 0, 1. Even 4-point DFT and odd 4-point DFT. Now we will calculate these values of Fourier transform by using this formula x of k a k plus omega n per k into b of k. Now we started from here: x0, x1, x2 and x3. First we will calculate separately values, which is 6, 4, minus 6 and 4. Then for this, by using the same formula of xn e की power minus j2 pi k n over n, we calculate these values: minus 2, minus 4, minus 6, minus 4. I can't do detailed calculations here because we previously discussed about all these calculations. Now we only use this formula a of k plus, this is a of k even values and this is b of k odd values, and omega n of k we use first omega 80, then omega 81, omega 82 and omega 83, and from here we use omega 84, omega 85, omega 86 and omega 87. By using this formula we calculate all these values: 4, 1.172 plus 2.82j minus 6 plus j, 6j and all these values. These values are familiar with the 8 sample signal values which we have already calculated. Now as previously we see, the addition rate is 56 and multiplication is 64. Now when we calculate separately for even values and odd values, the addition reduces to 32 and multiplication reduces to 40. 32 less than 56 and 40 less than 64. If these values come when we divide our signal into 4 point even and odd signals. If we reduce our samples into two values, then 2 even values, odd values, 2 even values, odd values. so the addition and multiplication rate further reduces to 24 and multiplication rate reduces to 16. So the worst case analysis for this 8 sample signal is O, worst case analysis n log base to n. One more thing which we discussed in this our lecture, for the audio signal maximum frequency is 4K, so the number of samples is 8K, and in voice the maximum frequency is 20K, so the number of samples is 40K, because the sampling frequency is equal to 2 into highest frequency according to Nyquist formula. In 1 minute 8K samples multiply 60, in 1 minute we have 480K samples, and if we calculate in 10 minutes we have 4.8 million samples. More samples is equal to more good resolution frequency. In our next lecture we will discuss in detail about spectrogram, and we have an assignment on spectrogram, so we'll discuss here. Thank you very much. That's all for today.